Hello guys, welcome back to my channel. In this video, I will talk about R language for data science. So I will start with one example so as to explain you what is the purpose of R and how we can use R, right? So let's say there is one data set from National Institute of Diabetes and Digestive and Kidneys Diseases. So they conducted a study on 768 adult female PIMA Indians living near Phoenix. The purpose of study was to investigate factors related to diabetes. Right, so this is my sample data, right? So there are various variables: pregnant, glucose, diastolic, triceps, insulin, BMI, diabetes, age, test. So we have to find the relation between these factors on diabetes. So if my BMI changes or insulin changes, how it will impact diabetes, right? So if any patient is diabetic, or if he is not diabetic but he has some tendency to become diabetic, so these kind of experiments are really helpful to come to some conclusion, right? So here we are using some statistical modeling to come to that conclusion, and for that R is one of the best language. All right, so now if I want to explain this data set further, my first column is pregnant. It says number of times pregnant. Second is glucose. It is plasma glucose concentration at 2 hours in an oral glucose tolerance test. Diastolic is blood pressure. Triceps is triceps skin fold thickness. Insulin is 2-hour serum insulin. BMI is body mass index. Diabetes is diabetes pedigree function. And age is age in number of years unit. And test is whether the patient shows sign of diabetes. Coded 0 if negative and 1 if positive. Now we have understood there is this data set with 768 observations, right? So we have this particular data set. Now we have to come to that conclusion. You cannot use Microsoft Power BI or any other data visualization tool to come to that conclusion, right? So for this, you need modeling techniques, statistical modeling techniques precisely, and for that, we will use R language. So how to start this program, I will show you step by step, and then going forward, checking the complexities, we can cover them in our upcoming videos. So basically, next videos will be all related to R and how we can do data science using R. All right, so you should know if you're using R language, you have to be proficient with statistics, right? So data science field is as such where you need to be proficient with statistics, mathematics, because there are so many formulas, functionalities, all the modeling, which requires your prior knowledge in statistics, right? So if you have zero knowledge or you have a little knowledge in statistics, then it's very tough for you to become a data scientist. This is my honest opinion. So for you to become a successful data scientist, first you have to, strengthen your basics in statistics, in mathematics, and then going forward with Python, R, and all those kind of languages, right? So now let's start with our basic steps. To formulate the problem correctly, first need to understand the physical background. So by physical background, it means that you should understand the problem, the domain that you're working in. So here we have this data set. It is related to medical, right? So you should have basic understanding so that you can make more sense out of the data set. Second is understanding the objective. So if you don't have any objective, if you don't have the clarity, then you won't be able to come to that conclusion which you want, right? So whenever you start your problem, you should have a defined objective. For example, in this case, my objective is to find the relationship between these factors on my diabetes, right? So this is very important. Third is making sure that you know what your client wants. So basically, you can do wonders, you can do so many good things with R, right? But you should know what your client wants actually, right? And finally, putting the problem into statistical terms. So once your problem is, equated in statistical terms, then you are already half done, right? So now let's see what is my initial data analysis. First of all, I would like to install faraway package because we need to load the data PIMA. So this is the data set, right? So this is already installed in the package called Faraway. So for example, if you want to call particular package, so you have to write install dot packages and then in parentheses you have to write the package name, right? So I will execute this. So I'll click on run. So now the system, you can see over here in the console, it will start running. Now it is showing cannot open the connection. Let's see if I click on library Faraway. So now it has been running. So if I click on data PIMA, so you can see this is for loading and displaying the data. So once you install the package and you call the library, right? And then go for data and then in parentheses your data name. So now you have loaded and just now go to PIMA and then run this. You will get the data. Now if you want to have a crisp data, you can just write head of. All right, 1 second. Head of timer, bracket closed, and then run this. So it will give me top 6 records, right? You can see pregnant, glucose, diastolic, triceps, insulin, BMI, diabetes, age, test. So you have all the columns with the 6 rows, or you can say 6 observations, right? You can also summarize your data. So using summary function and in parentheses again the dataset name PIMA. So once you run this, you will get the summary. So you'll get the minimum value, you will get the first quartile, then you'll get median, then you'll get mean, third quartile, and maximum. So you should understand the difference between mean, median, mode. This was the basic, right? So when we were studying in school, we used to study mean, median, mode. That is basics. So if you don't know this as well, so I would suggest you to study that first and then understand everything else, right? So once you understand this, there is a minimum value that is 0. Then in glucose also it is 0, diastolic it is 0, triceps it is 0, insulin 0. But do you think it is possible? Is it possible? So BMI can be 0? Practically no, right? So you have to observe these statistics, minimum value, median, mean, maximum, and then analyze what actually is wrong and how you can remove them. So these are all outliers or error values, right? So what we can do is, first of all, let me sort the variables to check the nulls. So for example, in diastolic, my minimum is 0. It is not possible, right? So I'll just click on sort and then in parenthesis, PIMA diastolic. So this is the syntax. So don't go with the R coding, what exactly I'm using. Just watch this video to understand the concept of using R, why we are using R, what is the objective, right? And then in my upcoming videos, I will explain you when to use summary, how to use these syntax and how to remember them, right? Otherwise, there are thousands of syntax. How can you remember? But there is a way, and then I will explain you in those videos. So now you can see here, if I sorted this column, so ultimately what I have done is table and then dollar sign and then column name. I have sorted this column. So now here I can see my almost 35 values are null. Initial 35 values are null. That means these values are definitely error values and I need to remove them, or I can replace them with some NA, because if you don't replace zeros with NA or any other error term, then for example, if you do average or mean, then it will consider these as zero values. But otherwise, these are not zero. These are, for example, there is no observation, it is blank. So you don't have to consider these values while doing mean, average, or taking mode. You have to ignore these values, right? Similarly with other columns. So if I talk about other columns, I need to do the same thing. For that particular process, I will set all the zeros to NA to avoid any error due to zero. So for that, I will take table name, dollar sign, and then column name. And then in square brackets, again table name, dollar sign, and then column name equal to zero. So I'm saying whenever my column value is equal to zero, then assign. So this is my assignment, less than and then dash. So this is equal to assignment. So in our coding, we will use this symbol for anything if we have to assign values, right? So what I'm doing is whenever the diabetes value is zero, I'm assigning it as Na, right? Similarly for glucose, right? So I'm doing this for, let's go back to summary. So if I go to summary, this is my summary. So my column pregnant, glucose, diastolic, triceps, insulin, BMI, right? So we have to work on all these things. So what I'll do is, so diabetes is done, glucose is done, and then I'll change here. Instead of diabetes, I have to do diastolic. Similarly here, I'll change it as diastolic, right? So now I've done glucose, diastolic. I'll go to tricep, right? So I've done glucose, diastolic, triceps. I have to do insulin as well. So I'll copy this and paste and change the column name to insulin, right? And then similarly for my BMI. All right. So I'm done with my six parameters, one, two, three, four, five, six, right? Pregnant minimum zero, it is possible. So I cannot change this. Let's run this, right? So now if you check after running each and every one statement, run, then running insulin, then running BMI. I could have ran all the statements together as well, but anyways, so now if I have to check my summary, right? Summary of PIMA. So you will see for glucose, it is showing me minimum as 44. And there is one more column NAs which is showing me 5. So there are 5 observations where it was 0. And here it is 35, 227 NAs, 374 NAs here, 11 NAs in BMI, right? So this is how it should be. Now, here if you see my test, minimum is 0. First quartile is 0, mean is 0.349. So this is my problem. Test can either be 0 or 1, right? So it can never be mean. So you cannot say ki test has been done 50%. So it's either positive or it's either negative, right? So we can never take these kind of statistics for such variables. So what we have to do is we have to factor it. So this is where the application of factor comes in. So variable test is not a quantitative but categorical. So this variable, it is not quantitative. So it's not like continuous. It's either 0 or 1, right? That means output is 0 or 1. In such cases, we need to factor them. For example, we have a column called pin code. So pin code can be 6000. 6000 is for Perth. Then pin code can be 6010. So you can't take the average of all these pin codes and say there is another pin code, right? So that is meaningless. So in those aspects, we have to factor. So for example, right now, see, this is how test is coming. I will do factoring of test, right? So here, as you can see, what I've done is table name, then dollar sign, then a column name. I have assigned factor of the same thing, table and column. So again, in this PIMA dollar sign test, I am getting the factored version. So if I do summary of test again, so you can see it is coming 0 and 1. A 0 is coming 500 times, 1 is coming 268 times. So if I do summary of PIMA, run, now you can see my test is coming 0 or 1. If you see previously, it was coming like this, right? So this is the purpose of factor. Second is we can assign the levels for both 0 and 1. So if we see over here test, it is either 0 or 1. But what is the significance of 0? So if there is a user, but he doesn't understand what is 0 and what is 1. For 1, I will assign negative. For 1, I will assign positive. So this is the vector. So whenever you have to store a variable as a vector, so you use C and then in parentheses the values, right? And I'm assigning this vector to my levels of PIMA dollar test. So if I execute this and then take a summary of PIMA, you will see my test is showing negative as 500, positive as 268. Perfect. So this is what we wanted. So far, so good. Right. So now we have a cleaned data set, better than my initial data set, raw data set. Now let's start to plot. So basically, whenever we start with histogram. So histogram will show me a couple of things. So let's go and run this. For histogram and other stuff, you can just drag this screen and under plots, you will see those graphs. So there is packages. So if you want to import or install any package, you can install from here. There is help, there is a viewer, presentation, and there is plots. So this is where I have to see the plots. All the graphical representations will be coming over here. So here you can see my frequency of diastolic. So it is going from 20 to 120 something, right? And majority is towards 70, right? So frequency, you can see it is more than 200 between this, right? So I can understand this, that my majority is somewhere around 70. And better way of doing this is using kernel density estimates. So this helps in avoiding the blockiness. So you can see this is the blockiness of histogram. So instead of that, I can run this. So this is how the output will look like. So what I've done is I've used plot density and then under that table name dollar column name and comma na.rm. So I'm saying remove is equal to true. So I will explain you all these coding, all these kind of R language syntaxes in my upcoming videos. Just follow the concept right now, right? So we are done with this. Now we have understood how the values are flowing. Let's understand linear models now. So as you know, uh, if we have to see the effect of any particular variable onto another, so you must have worked on y is equal to mx plus c as my equation. For example, there is one equation y is equal to mx plus c. So what does it mean? So that means there is one straight line where y is dependent on x, c is my intercept, and m is my slope. What do you mean by that? C is intercept. That means how, if my x is 0, y is equal to c, right? So my line will intersect with y axis when x is 0. So that is the point which gives me the intercept. And m is slope. That means the angle at which the line is covered through my x-axis. Alright, so for this, if I have to check how my y value will change using x, here my x values are diastolic and all other things, y is my diabetes. So what I'm doing is I'm checking the relationship between diabetes and diastolic. So for that, I will use plot and then diabetes and then this symbol. This shows that I am plotting between these two, and data I'm using is PIMA. So I'll just run this. So this is how my scatter plot is between diabetes and diastolic. Similarly, if I want to check this between diabetes and test, I'll just run this, and here you will get the box plot. So you know test is my uh, categorical variable. It is not continuous, right? So it will be either 0 or 1, so negative or positive. So this is why I'm getting box plot over here. And if I check the pairs of PIMA, if I run this, you'll get so many graphs over here. So if you see here, all the relationship between pregnant, glucose diastolic, between each and every variable you have the patterns. So I will explain all these things. It is a very interesting concept. Working on R is really interesting. It is challenge if you don't know anything, but we'll go step by step. We'll understand each and everything, and in the next couple of months you will understand everything. So I just hope you follow all these videos in my upcoming sessions, and if you have any suggestions or feedback, just let me know so that I can add those concepts as well in my upcoming videos. So till then, take care and continue studying R.